This video contains graphic scenes of various burns and injuries incurred from accidental contact with low and high voltage electricity. These scenes have been used to realistically portray the dangers of improper contact with electricity, no matter what the voltage. The operator of the facility where this video was shot allowed the staging of certain conditions which appear to be unsafe and not within federal, state, or company safety procedures. These scenes were created strictly to demonstrate the differences between correct and incorrect safety and work procedures in the mining environment. They were immediately corrected after being recorded for this training video and are in no way a true reflection of the conditions or operation of the facility shown. Modern mining runs on electricity. Electricity powers conveyors, crushers, ventilators, and lights. Electricity is raw power, so you have to treat it with respect. Electrical accidents can hurt you or kill you. That's why the mining community created procedures and laws to help miners stay safe while working with electricity. Problem is that a lot of miners seem to pay more attention to the hazards and safety procedures of high voltage electricity than those of low voltage. That's a mistake, because more people die of low voltage electrical accidents than high voltage. So in this program, we'll talk about the difference between high and low voltage electricity, common electrical terms and meanings, the dangers of low voltage electricity, safe work practices, and rescue and firefighting. Keep in mind during this video, we can't cover all there is to know about low voltage electricity. And we don't know the individual details of your mine or plant. That's why we encourage you to work closely with one another at your operation to make sure safe work practices are always followed. The Mine Safety and Health Administration, MSHA, defines low voltage as 650 or fewer volts. But it's the common voltage we find in our homes and workplaces, 120 and 240 volts, that causes the most accidents. That's why we'll be focusing on these two voltages. Let's define some common electrical terms first, starting with volts. Voltage is the pressure needed to push electrical energy to where work needs to be done. Run a motor, light a light. In very simple terms, we can compare voltage to water pressure in a pipe. The greater the water pressure, the more water that flows through the pipe. In a wire, the greater the voltage, the more current that's pushed to do the work. Current is measured in amperes. Most of us say amps. And it's the amps, not the voltage, that does the damage when electricity hits you. And it takes very little amperage to kill. As little as 20 milliamps. That's 21 thousandths of an amp. When you consider that a common impact wrench draws 7.5 amps, 20 milliamps is not much. Electrical resistance, measured in ohms, tells us how easily electricity moves through a conductor. Good conductors have little resistance to the flow of electricity. Wires and cables used to deliver electricity are made of good conductors, usually copper or aluminum. Poor conductors are called insulators because they resist the flow of electricity. Insulators can be used to keep electricity from straying. Wires, which are good conductors, are often wrapped with a non-conducting insulating material like rubber or plastic. That material keeps the electricity from finding other conductors, like you. Because under certain conditions, the human body is a good conductor too. In some applications, such as high voltage transmission and distribution lines, there is no insulation around the conductor. That means stay away unless you are trained, qualified, and authorized. Electric current always flows from areas of higher voltage to areas of lower voltage, the ground. The Earth has 0 volts, so electricity, no matter what voltage, always tries to get to Earth or ground, and it always follows the path of least resistance. So what if that path is you? The dangers of electricity can be divided into 3 categories: electrical shock, flash burn, and fire and explosion. Electrical shock effects can range from minor irritation to cardiac arrest. The most common symptoms of electrical shock are muscular contraction or muscular control failure. Contractions often cause the victim to grab the source of the shock and be unable to release it. Muscular control failure can lead to falling from an elevated location. Electrical shock can stop your breathing and keep your heart from pumping. Electrical current flowing through a body generates heat, and this can cause severe tissue burns on the body's surface or deep inside. Consider this: most human tissue is destroyed at only 120 degrees Fahrenheit, and brain tissue damage occurs at less than 110 degrees. Even a contact as brief as 1 second with an ordinary household 120-volt, 15-amp circuit can generate enough heat to destroy tissue in the human body. Another important factor related to electrical shock is the specific path of current through the body from conductor to conductor. For example, a hand-to-hand pathway is especially dangerous because it passes through the heart. Skin condition is another variable. The human body becomes a better conductor when skin resistance is lowered as a result of being damp from sweat or rain. If you feel the telltale tingle, tell someone to identify and repair the problem right away.
I just got shocked by an outlet. Can I show you? Yep.
Remember that electricity travels at the speed of light, and you can't see it. And the effect of a shock is dependent on so many factors. No shock can be considered harmless. The next one could be much worse. The second major source of electrical injury is flash burn from uncontained arcing. Under certain circumstances, for example, when extremely high voltages are involved, the insulating capacity of the air can be overcome and electricity will jump from one point to another. This is called arcing. Lightning is a natural form of arcing. Arc welding is arcing. And electrical arc generates extremely hot ionized gases, which, if not contained, are capable of causing serious flash burns on the body. Arcing also generates ultraviolet rays, which can injure the eyes and skin. If you work where arcing is a possibility, wear flash and flame-resistant clothing, as well as face protection. Protective equipment has saved countless lives. In addition to flash injuries and burns, electrical arcing can also be a source of ignition. This causes the third major source of electrical injury: fire and explosion. Ignition of combustible vapor or dust can be caused by electrical arcing or sparking from a variety of sources, some of which you may not expect. Many electrical motors, including those used to drive battery-powered screwdrivers and drills, produce continuous internal arcing during normal operation. Relays, switches, actuators, distributors, and other electrical devices produce sparks each time they function. Even tiny electrical sparks from sources such as the switch of a battery-powered flashlight or a cell phone can be enough to trigger an explosion or fire if flammable vapors are present in the proper mixture. For this reason, pneumatic or hydraulic-powered equipment or non-sparking hand tools should be used wherever there is any possibility that flammable vapors may be present. Fires of electrical origin are quite common. Use only dry powder or gas extinguishers to combat these fires. Never use water to attempt to put out electrical fires. Probably the most common exposure miners have to low voltage danger comes through the use of common power tools like drills and saws. Before you plug it in, Always inspect the tool you're about to use. Look at the cord. If it's cracked or badly chafed, you're dealing with a hazard and it needs to be corrected. Is the start-stop switch in good condition? Is the plug in good condition? Is the ground prong there? Have you ever seen one clipped off? That's a bad idea. Is the outlet intact? When you plug the tool in, is there evidence of a faulty connection? Keep guards in place and remember, trigger lock devices are never to be used. That's the law. Be aware of overheating, excessive sparking, the smell of smoke. They're signs of trouble and potential danger. Get into the habit of picking up a tool this way instead of by the cord. Check out the extension cords. They are to be used for temporary service only and unplugged when not in use. Don't plug extension cords into each other to lengthen them. And if you need to reach farther than 100 feet from an electrical outlet, use a temporary distribution box, not an extension cord. Remove the cord from its connection by grasping the plug, not by pulling the cord. Putting stress on the cord can cause unseen damage and future danger. If the molded cap at the end of the cord does get loose or damaged, replace the whole cord. A repaired cord is not reliable or safe. Use the right kind of extension cord. It must be a 3-conductor grounded cord. For saws, grinders, or impact hammers, use a 12-gauge cord. Bigger tools like compressors call for thicker 10-gauge cord. It is not a good idea to use extension cords in wet areas where destructive chemicals are used or where welding or burning operations are in progress. Extension cords are a frequent tripping hazard. Keep them away from common walking routes. And make sure you store extension cords properly. Remember, if you get shocked, no matter how slightly, let your supervisor know right away, because you have 2 problems: stray current and a poor path to ground.
I got shocked by this outlet.
Ground fault circuit interrupters, GFCIs, are inexpensive safety devices which can detect a tiny amount of current imbalance and stop the flow of electricity. Think of them as sensitive circuit breakers that activate when current flows into the ground instead of between the 2 primary conductors. You've seen GFCIs in bathrooms and similar locations where they are required by the National Electric Code, NEC. They're also required when used with tools and extension cords in potentially wet conditions. They save lives. Whenever throwing a breaker, stand to the side and turn your face away. It's rare, but breakers have been known to explode. Always follow proper lockout and tag procedures. What should you do if someone is in contact with live electricity? Always follow these rules. Protect yourself. Don't touch the victim.
Hey, Brenda's getting shocked. Don't touch him.
Yell for help to warn others. Shut off the power.
Okay, power's off.
When the victim is free of the electricity, check for consciousness, breathing, and circulation. It's possible that immediate first aid, including CPR, could save a life now. Electricity is an essential source of energy which keeps the mining industry running. But that power can turn against you if you mishandle it. Understanding the hazards and knowing safe work practices is what keeps you safe. In the last few minutes, you've become more aware of the hazards of electricity. You've learned common electrical terms and their meanings, and seen the specific dangers of low-voltage electricity. We've discussed safe work practices, rescue, and firefighting. You now have the knowledge you need to keep you from becoming a statistic. Remember, breakers can be reset, lines can be replaced, power can be restored. But if low-voltage electricity puts your lights out, You can't be. And you may not get a second chance if you bypass safety.
Tell them I'm calling CPR.